All right, well, welcome back, everybody. So far, what we've done is we've read our analog read. So all of our XY, RX, and RY values should be stored as either somewhere between 0, meaning the joystick is all the way at the bottom, all the way up to 1023, which means it's all the way pushed to the top, or then 512 is right in the middle. So somewhere between there's a value stored in there. So if you were to connect this to your robot, this should be reading, and you could test each direction to make sure it's the correct one reading into the correct variable. But for now, one last thing we need to do. On this chunk of code, the last print here should have an LN on it. That'll knock it to a new row. All those other ones will be on one row next to each other, and then it'll knock it down. Also, to make it easier to read, when we print it this way, this LY is going to be smashed right against the number inside this XL value. So we might want to put a space out in front of these three, not this first one because it's the first one on the far left. You don't need that space to differentiate it. That might make life a little easier. And maybe just to make the line a little smaller, I'm going to take out this space in front of the equal sign, tighten my stuff up a little bit. So that should be a really nice print. For now, though, I'm going to just comment this out. So I'm going to highlight all of these rows, Control/. That'll comment those out. They won't be on right away. All right, next thing we need to do is we need to convert. So right now, if we were to try to use the number stored for each joystick, if we added like off plus off, we should get off. That makes sense. But when we add it with these values, we'd get 512, which is off, plus 512, which is off. And that would be 1023, which is full blast. So we don't want that. We want more reasonable numbers to work with. So next thing we're going to do is we're going to take these values and map them to -100, meaning full speed backwards, +100, meaning full speed forward, and 0 in the mid value. So let's do that real quick. So I'm going to create a map function. I'm going to use the map function here. And I'm going to map the LX val. And then it takes 4 numbers. So the computer needs to know what's the starting range of these values. Well, they start at 0 and they go to 1023 at the highest. And then it needs to know what range you're shooting for. Well, at lowest we want -100, comma 100. And so what that's going to do now, it's going to take LX val, it's going to do all the math required to transform it from 0 to 1023 down to -100, 100. So all those will be mapped down to that new range. Again, though, it will instantly just forget this information. So I need to tell it where to store it. And here I'm going to store it right back in LX val. So I'm going to type in LX val here. Now I could make a new variable for like mapped LX val, but because I don't ever need this number again, this analog number, I don't need to hold on to it in a separate variable. I can just override it as soon as I do the mapping. So here it's going to take the old LX val, convert it to a new number between -100 and 100, and then erase the old number we had and put it back in there as the new number. All right, I'm going to wait. Let's go get a comment in real quick. So this converts the analog number, analog values that were 0 to 1023 to -100, 100. So it just converts them from this range to that range and then stores them back in LX val. All right, I'm going to pause the video here while I update this. I'm going to do 4 copies of this, 1 for each of my directions. You do the same. Okay, so I've got those 4 things updated. Make sure you updated both of them, so LY with LY, they should all match each other. Now I want to do another quick serial print, and it can actually be the exact same code from up here. I'm just going to copy and paste this down below onto this line here. And later when I want to test this, if this is working, I'm getting the correct, I can then comment this out and comment this back in, and then see if that conversion is happening. Now I should be getting values from 100 to -100 for each of the directions, so you can check to make sure that works. I'm going to run a quick check here just to make sure I haven't added a bunch of code that's all broken and messed up. And it looks like I'm good, so I'm going to keep moving on. If something is broken, fix it. It's easier to do it now than later. All right. So now that we've read it, we've gotten the values together, we need to now add the joystick values so that we have one, we can calculate the motor speeds for each one based on those joystick values. So to do that, we've done this equation work already. We're gonna execute it here. So I'm gonna start with my left front motor, and I'm gonna give a variable called speed. That's where I'm gonna store the speed of my motor. And to find this speed, I know I've got to do the ly val, ly val, and I've got to add to that the lx val, and add to that the rx val. I just noticed I did an equal sign instead of an addition sign, so there. So this calculates the motor speed. So I'm going to do a semicolon to end the line, // for a comment, and then this calculates the motor speed from joystick values. Okay, so we're taking, in order to find the left front motor speed, we figured out we needed to add the ly value plus the lx plus the rx. That gives us the motor speed value. All right, now I need to do that for the other ones. So I'm going to copy and paste this and just start switching stuff around a bunch. Control V. And that's my 4 equations there. And this is going to be for the right front motor. This is going to be for the left back motor. And this is going to be for the right back motor. Left front, left back, right back. And then the right front motor is going to be the same thing, except we're going to reverse this LX value and reverse the RX value by putting them both negative. LB, we're going to reverse the LX value. And we're going to reverse the RX value. And that's just from our previous lessons what these equations are. And now they should be working nice. The only thing I noticed here is that, well, let's go ahead and check it real quick. We'll throw an error and find out. Just do some practice figuring out what the errors are. Awesome. So the error is going to tell me here is that it is an undeclared, which it means that I have either misspelled it or I never created the variable in the first place here. Error, L motor speed was not declared. Okay, great. So we can go up and declare it. I'm going to double click on left motor speed and come up here and create this variable. And this one I'm going to do down here with the values because it's not a pen. And I'm going to do an INT in front of it. And then equals, and then my left front motor speed, maybe 1500 because that represents an off. All right, and then creates a variable for motor speed values. I'm going to pause the video while I make the other 4 of these, and you do the same. All right, so I've got my 4 motor speed variables created here, so this should be working just fine. Do a quick check just to make sure I haven't made any other errors. Amazing. All right, so now we've read our joystick. We've converted from -100 to +100. We've added and subtracted them all together to make everything work pretty well. And now what we need to do is some of this, like when we add LY plus LX plus RX, if they're all maxed out, that's going to give us a motor speed of 300%. And we just don't want to send that to the motor. So before we move on, we're going to create a cap. So we're going to say, hey, if it's above 100, if it's like at 300, make it go back to 100. We don't ever want to go over 100. And if it's less than -100, bring it back up to -100. To do that, I'm going to use an if statement. So I'm just going to ask the question, if, and I'm going to come up here and copy and paste my left motor speed. If this is greater than 100, I'm going to be able to set it back to 100. So to do that, I'm not going to use a semicolon here because that would end the if statement. It wouldn't even start it open. I'm going to open the if statement with an opening curly brace. Notice Arduino puts in a closing one for me. Hit enter. Let me open up some space down below here so you can see. I didn't delete that last curly brace. Just it's off the screen. And now I'm going to say if this is greater than 100, Control V for left motor speed equal to 100, semicolon. I'm going to come up here and do a quick comment on this first line, and this sets the maximum value of the speed to 100. So that's what this little if statement is for. And then we come down here and I'm going to grab one more line down below and enter Control V. I'm actually going to put this up here. And now I need to ask myself, do I want two separate if statements or should I have an if else here? So this left motor speed is going to be for greater than, this one's going to be for less than negative 100. And when it's less than negative 100, I want to set it back to negative 100. All right, now I'm ready to think about whether I want this to be, so actually I want this one to be, now let me do this first. Minimum speed to negative 100. Well, that's a faux instead of. All right. Now I think, should this be an if or an if else? So when I use an if, is if both things could be true at the same time. I'd want to check both of them all the time. But I know right away that if the left motor speed is greater than 100, it's definitely not less than 100. So I could leave it like this as two ifs, or I could do this. I can make this into an else if. And what that does is an else if pairs up these lines of code with the previous if. So if this one runs, if it's greater than 100, it doesn't even bother looking to see if it's less than 100. It skips all of this code and moves on. That'll make your code a little bit faster and it'll use a little bit less battery. It's not crazy important, but it's a cool thing to think about. It'll help reduce the amount of global warming there is by using less battery, which is kind of a cool way of thinking about it. And all I've done now is to make it visually linked to the if statement, I've just put the if else at the end of this. It makes no difference. It could be right there as well. It's just whatever you prefer it looks like. In fact, I think I prefer this look. All right. So now I'm going to copy and paste this. I'm going to copy and paste this 4 times, one for each of the motor speeds. And you'll notice as well right now that we've ignored the vertical motor. It's just totally different. It's much easier to do. We'll do it later. So I'm going to copy and paste this 4 times and change all the variables around. I'm going to pause the video. When you're ready, hit the play. All right, so I think I have all of my variables and stuff renamed. So I've got one set for right back, one for left back, one for right front, and one for left front. I'm gonna do a quick check just to catch any errors. I actually probably should have done this before I copy and pasted everything, because if I made an error, I just copy and pasted it 4 times, I have to fix it 4 times. So, you know, hey, I got lucky. All right. Let's move on now. So now we've read the joysticks. We've mapped them to a new value between negative 100 100. Then we've added and subtracted them together to get all of our motor speeds. We've made our motor speeds sensible by saying if you're above 100, go back to 100. Don't ever go over 100 or below negative 100. And now we need to send those motor speeds to the actual. Let's actually do a quick serial print here and check them real quick. So I'm going to add in this serial print values. I'm going to come grab these. I'm going to put them right down here and see if I need to change anything. Actually, I think I made a mistake earlier. Let's go take a look. Nope, that was all good. We actually need to put another set of serial prints in here so we can just serial print and see if this addition subtraction thing is working properly. But let's fix this first one. So right now we're not actually trying to see the LX value, we're trying to see the motor speeds. So here I'm going to change this around to the motor speed one. So my left front motor speed, so I'm going to just do this as LFM to keep it short, and then I'm going to copy and paste this down here and change it around for all the rest of them. So this is left front, this is going to be right front, this is going to be left back and right back. And then here all these values need to change as well, so I'm going to take the right back and line it up with right back. I'm going to put in all of these and then switch them to the right one. So this should be left front, and then this should be right front, and this should be left back, and that one's right back. Okay, so now all of these match up. This will allow me to print to see if my if statements and else if statements are breaking stuff or allowing it to work. I actually need to add this exact lines of code above the if statements. Open up a couple lines of space, line up this one so it looks nice. And then here, these serial prints will allow me to test just to see if my addition and subtraction is working properly, so I'm getting reasonable values. Although here I'll be getting some 300s and some 200s and whatnot. And then down here will let me see if my setting the maximum of 100 and negative 100 is working as well. All right, so that's it for now. The third video, we've got a few things left to go. We need to add in some stick drift code so that when we're sitting in the middle of the joystick, sitting in the middle, we're not floating around, moving around constantly because our motors are still spinning. And then we just need to send the motor commands out to the actual motors to have them fire. Great job, everybody. We'll see you in the next video.